Hello, everyone. I want to welcome you all to the talk today. The title of this talk is Are Your Pipelines Secure? And in this talk, I want to be generally talking about DevSecOps and how you can ensure your CI/CD pipelines are optimally secured. So here's a quick agenda for what I'm going to be talking about today. I'm going to jump into a quick intro, then talk about the software development lifecycle and how it relates to continuous integration, continuous deployment, as well as DevSecOps and pipeline integrations, and then following that up with securing those pipelines with a quick recap of all the topics, ideas that we talked about. So my name is Angel Rivera. I'm a developer advocate for CircleCI, and my job is essentially to communicate and engage with the developer community on behalf of CircleCI. I started my career off in the United States Air Force, United States Air Force Space Command, and I've worked in many organizations, right, ranging from military all the way through to enterprises and startups. Currently, I'm working for CircleCI, which is an awesome job working as a developer advocate. So I get to engage the developer community, learn how people are using technology, learning about some of the awesome things they're doing with the technology, as well as some of the obstacles and issues that they're encountering with technology. So it's a nice role to be in to understand, throughout the whole industry, how folks are either flourishing and innovating with technology or how they're struggling with technology. And this talk is based off of a lot of that interaction that I've had. So the first thing I want to do is talk about the history of software development. Now, the history of software development has a lot of aspects to it, right? But what I'm going to focus in on is software development practices, and specifically software development lifecycle type practices. So the first thing I want to talk about is kind of where I came from, my career. When I first started building software, we were using a waterfall development methodology, which is kind of old school. Actually, it is old school. But at the time, it was pretty much all we had in the sense of development lifecycle practices. So this is what it looks like, kind of, if you were to graph out the waterfall development lifecycle or methodology. And the way it works is, requirements are generated, then they're doled out to program managers for that system. And then those program managers go ahead and separate the work out a little bit more. But all the while, the work is, number one, very lengthy in in volume, right? So with the waterfall methodology, tasks were broken out into more of a general, right, sense. Not as broken down into individual tasks until later on. The problem with the waterfall development process or methodology is that everything's kind of interdependent, right? So tasks that are doled out to teams have to be completed before another team can start working on another task within that waterfall development methodology, right? So everything's kind of interdependent, and the tasks are then, or the green lights for tasks are then cascading, right? So they again, one task has to complete before the next can begin. So they're all kind of interdependent. As you can imagine, that brings a lot of wait time, right? So if you have a huge development team and they're waiting on previous tasks to be completed before they can start working on the stuff that is going to be assigned to them, then you're going to have basically like long wait lines, right, until things are completed. Which, again, when we first started developing software at that stage using this methodology, it's kind of all we had at the time. But, as developers and as technologists and people working in technology, we got a little bit smarter. And we realized that the waterfall methodology was slowing us down way too much. So what had started to happen was developers, in the space and thought leaders in the space were developing these new ways to develop software that were, faster and more efficient. So that's where the agile development methodology was kind of born out of, right? Is basically the ability to take those big tasks that were, kind of pushed down to us through the waterfall development process and breaking them out into smaller, more manageable tasks, right? So It's just like anything, right? It's almost like the agile methodology can be, at least I kind of interpret it as a concurrency, right? So the ability to leverage concurrency, doing things at the same time, multitasking, and that's essentially what's at the heart of at the agile development methodology, right? It's the idea that you can do multiple things at the same time as long as you break those tasks out into smaller, more manageable bites, right? So you can get more productivity out of developers. If you can look at this this diagram, you can see a lot of movement, right? A lot of circles with arrows, a lot of smaller sub bubbles, I guess, or circles that are attached, but all the while everything's connected, right? So again, with the advent of the agile development methodology, things just got done faster, right? Because they were broken down into smaller chunks. And again, if you had a pretty good sized development team, you're iteratively working so that folks were just finishing tasks off and then going back and getting another one. All the while, things are being pushed through the whole process. So again, right, agile versus waterfall. Waterfall is a cascading, dependent type of methodology where you're blocked generally if something is not completed. The other teams can't get started. Whereas agile, everything is happening at the same time and speeds things up, makes things more efficient overall. So with that pattern of agile software development came this new concept of continuous delivery. So not only are we developing software faster because we made things we broke them apart, decomposed them into smaller chunks, and then people can work on them, and then iteratively changes were pushed back into the main code branch. Continuous delivery offers us that same kind of pattern, right? So we were able to now take what we've done in principle with software and then apply those same concepts to the delivery of that code, right? So in a technical aspect, once we start building the code, we could actually continuous deliver those changes, right? So that's where that continuous delivery kind of comes from. And then from there, continuous integration and continuous deployment kind of was born out of, right? So if you have continuous delivery, you can now implement continuous integration and continuous deployment practices. And if you've ever heard of the term DevOps, which is basically, in principle, is where you're taking your development team and your operations teams and you're building a stronger relationship between them, basically knocking down any kind of barriers between your development and operations teams so that they basically operate in the kind of this fluid motion that you're seeing on the screen, which is the continuous integration. I call it the continuous integration infinity loop, right? And you can see there's tasks, right? Like planning, code, build, test. Those are all more developer centric, right? On the continuous integration side. And then the release, deploy, operate, and monitor sections kind of relate to the operations side, right? And by the way, this is not set in stone. This is just a general kind of concept so that folks can visualize and understand the CI/CD and DevOps relationship. So with continuous integration on the development principles, right? If I'm still going with that concept of dev and ops, basically what's happening in there is what you're doing is continuously writing and committing code to a shared repository as often as possible, right? So again, if you think back to the agile methodology diagram that I shared, right? Things are constantly moving, constantly being pushed, and a lot of things are being done at the same time. So taking that agile methodology, pushing it down into the way we collaborate around code is continuous integration. And these are just, again, in principle only, right? Right now what I'm talking about are just principles. The idea is also to test your code on every commit so that you ensure that you're pushing the best quality code right into these repositories. And finally, one of my most favorite benefits of continuous integration is fast feedback loops. What I mean by that is being able to understand what's happening with your software, know as quickly as possible when you have issues with your software, right? So that's basically continuous integration. is again, right, writing and committing code as often as possible to a shared repository, testing that code, and then being able to get feedback on those changes as quickly as possible. With continuous deployment, like again, more on the operational side of things, as principles go, it enables you to create these release artifacts, right, for your deployment processes. And it also allows you to deploy those code artifacts, right, or those artifacts to resources. So that means, pushing this newly changed and packaged up code up to maybe a Kubernetes server or such. Then it also enables you to validate and monitor the state of those services, so that you ensure that your application is up and running optimally as often as it needs to be, or keep it keep a type of monitoring or observability state to the system. So again, these are just in principle, right? But in order to make all of this a reality, right, we have to leverage automation. So we can talk about sharing code and collaborating around code, and feedback loops, but none of it is possible without automation, which means we have to put some sort of technology behind it. And that's where the concept of CI/CD pipelines come in. So we talked about continuous delivery, continuous integration, continuous deployment. And I'm sure you've heard the term pipelines. And that's what pipelines kind of do, is take all of those processes that you're using automation on, right, or using to automate, and then kind of lumping them all together in a logical kind of grouping, right? So here's what a continuous integration, continuous deployment pipeline looks like in the CircleCI dashboard. As you can see, there's a couple of blocks of things there. Those are jobs. So these are actions that need to take place in my CI/CD pipeline, right? So this is what I talked about, adding the automation to my processes. This is exactly what I mean by that. Is running, first you have to code up or configure your pipeline to basically define these actions, and then running them through the automation is where CircleCI comes in and provides the tooling to do that. And if you're using any kind of tools right now, you may have a different kind of dashboard, but for the most part, they all have similar dashboards and kind of notification platforms, right? But again, this is just a CI/CD pipeline shown in the CircleCI dashboard. So with those pipelines, though, right, you saw a lot of jobs, things were integrating into like Kubernetes or GKE and other systems. These pipeline integrations definitely, require you to connect to external systems. Some of them being, right, these are some of the types of integrations that occur within pipelines. App code coverage tools. So you're checking your code within those toolings. You're doing vulnerability scans, right, using tools within your pipeline. API requests. Maybe you're calling out to some other service, right, to get information, to get data that you use in your pipelines. And on and on. It can go on and on. But basically, your pipeline, when you're using that automation, is definitely going to integrate with a lot of other things and other services. So I talked about DevOps lately, but what I want to jump in on here is this term DevSecOps, right? So when DevOps was, being adopted or implemented, security has always been there as part of an element of DevOps, but it wasn't really focused in on, right? I think folks were just, getting their heads around this culture shift in this DevOps space. And security is one of those things where, I don't know about you, but I've been in organizations where security teams and organizations within security organizations within a company or other entities, they're kind of separated out, right? For whatever reason, they're just kind of on their own and almost like an afterthought in some cases. I hate to say that, but generally security practices or actions are taken at the very end towards the end of a software release. But with DevSecOps, there's this concept of kind of bringing those actions to the forefront of things, right? So no longer are you waiting to the very end to perform scans and such on your code. The idea of shifting left means moving those actions to the forefront, right? So to the beginning of your CI/CD pipelines. and not towards the end. So when we talk about shifting security left, it just means moving those security practices and actions up front, right? So that not only are you testing your code when you're pushing changes as a developer, you're also doing maybe some security checks, right? Now, prior to this, this shift left kind of movement that we have in current days, security again was kind of like considered outsiders, right, to the group. Now, I talked about DevOps and merging developers and operational tasks together. DevSecOps does that with security as well, right? So now we're trying to push all of that to the forefront, as I said earlier. Now, when we're integrating actions into our pipeline, security actions into our pipelines, that can come in many different forms, right? So one of the, I guess, general terms I use for that is pipeline security scans, right? So now, with all this awesome tooling that's coming around, developers are now more educated and more empowered to be able to partake and be a little bit more invested in ensuring that the tooling and the code that they're writing is actually is secure. So the way that we're doing that now is by executing these awesome new tools from companies out there, right? That help us developers now understand the security landscape. So it makes it really simple to just say, okay, here's a tool that I need to scan my application, right? And ensure that the code libraries that I'm using, maybe some of the dependencies that I have in my code are secure enough that I can package them up in a release. As a developer, right? I don't need to consult with a security team or an operations team member. I can just do this on my own. And the way we do that is by performing static analysis, scans, right, within our pipelines. Again, because we have these awesome new tools, we're able to properly engage as developers without a lot of assistance from a security team, right? The tools will also enable us to do things like a container vulnerability scans, right? So now, not only can we do like the static analysis type scans, we can also, when we package our applications, let's say we're going to deploy to Kubernetes, we need a container for that. Now we can scan those containers and we can use the tools that are provided to us to easily be able to do that, right? And the tooling today is pretty awesome because if there are any issues, the tools will detect them, and the tools will generally offer, not only will they tell you have issues, right? And it gives you a severity of low, medium, high, or whatever the severity items are, but you also have the ability to also get some remediation type advice, right, from the software, which is pretty awesome. So the developers, again, can quickly go in, fix those issues based on the remediation data, and then rerun those scans, right? So again, it's not involving the security team directly for every scan, and it's also helping, when we're shifting those things to the beginning of the pipeline, helping us be more confident with the software that we're releasing as developers. So what I described is just one of the many CI/CD pipeline obstacles that we face as developers, especially in the security space. But what I want to talk about now is actually securing pipelines, right? So what I talked about was kind of more code-centric, which still I consider securing pipelines. But again, it was more of a focus on like shifting left and understanding what that means. But what I want to talk about now is one of the most painful, I guess, for me at least, when it comes to like a security aspect, some of the issues with some of the CI/CD tooling out there today. One of the things that, again, I mentioned earlier was our pipelines need to access other services, right? So that means they have to integrate. And when you have an integration, you need access. And that comes in the form of basically credentials, right? And those credentials can come in the form of OAuth authentication, access keys, API tokens, certificate-based authentication. You have a list of different ways to provide credentials or different forms of credentials, right? And then you also have, right, the old regular old username and password, right? So all of those access types, access types or credentials, I like to call them secrets, right? And I think that's becoming more of a general term used within the industry. Because that's basically a secret is just sensitive data, right? But again, secrets provide access to systems and other services that we're using within our pipelines. But with having that access, right, and then leveraging the automation, those secrets must be protected. Otherwise, you risk an exposure, right, or a vulnerability, or an access where bad actors can gain access to your pipelines and your operations, which is pretty bad, right, if that happens. Some of the problems, though, with CI/CD tooling today and the way we manage those pipelines is pretty obvious, right? And actually not very new. So what I have up here is, one of the biggest issues that I see right now is folks are not keeping up to date with changing passwords, right? So or secrets, I should say. So you have like weak or stale secrets that sit around for, could be months up to years. Which basically provide a bad actor a more acceptable, not acceptable, but a more risk of accessing the secrets, right? So you're basically leaving them a bit of a door to be able to go ahead and access information. Another piece that is something that I kind of want to address is, when you have those secrets, even like, let's say the secrets are generally stored securely in these CI/CD platforms. And again, right, your pipeline jobs, not all of them need secrets, but some of them do. And generally the ones that access integration services or integrate with something need secrets, right, to access. One of the things that is currently happening within pipeline CI/CD platforms is that the secrets that we have for those integration points are stored, on the platform securely, right? They're on disk at rest. They're secure. When the CI/CD pipeline automation or the jobs need any secrets, then they're pushed from that secure sitting at rest, and they're pushed through the wire. In flight, they're secure as well. But once it hits the runtime where your CI/CD jobs are running, then they are unencrypted, obviously, right? So that the systems can then leverage those credentials and pass them on to do whatever transaction they need to do against that system, and then they should go away. But I can tell you that when the runtimes, grab those security secrets or the secure data, they unmask it, and they can do a better job of keeping those more protected in the runtime. Because again, if a bad actor gains access to that runtime while those secrets are unmasked, they have the potential to capture those credentials and exploit your system, right? So there's a lot of moving parts, especially with automation. And one of the things that we can do to prevent that is basically what I call secrets management, and that's essentially just implementing and adopting tooling to help protect those secrets. What I mean by that is there's tools out there that will enable you to kind of keep or generate all of your secrets in. So basically managing that interaction between any kind of system, really, but in this case I'm talking about pipelines. So you store your secrets in this the secrets management tool, and then you're able to then have your pipelines call that tool and pull in secrets when it needs to. When you're leveraging a tool like that, right, you're going to be able to do things like generate random strong secrets, right? And that's a really cool thing because the system will then do that for you, right? You don't need to have a manual interaction with generating these secrets. You don't, you don't have to create something that you'll memorize. You just let the system do that for you, and the system will then, be able to do what we call auto rotation. So not only are they generating strong random secrets for you, they can actually rotate those secrets based on a policy that you specify, right? So in one case, I had a customer tell me that they hadn't changed secrets in their pipelines in 5 years. And when I asked them why would you let that last for that long, their response was, I'm afraid of what it will break if I change those secrets, right? So again, one of the things that we should be looking for is generating new strong random secrets, and then also have the capability to auto rotate those secrets so that when your pipelines call out, need to call into another system, you've got some fresh credentials that are generally rotated out. Anything right now, people ask me all the time, like, what's a good kind of rotation schedule or cadence? I would say just start with something, right? Even if it's like once a week, start with that, and then slowly, progressively work your way down. Like rotate the secrets every day, right? Then you can go to maybe every hour, depending on whatever it is that you have as requirements, or whatever you want to achieve. But definitely look into the secrets management for the capabilities for auto rotation. With the secrets management tooling as well, you can get granular access controls, right? So this is great for auditing if you're in a regulated space, which I think, anyway, it doesn't really matter if you are in a regulated space anymore. You definitely want to know, if you're implementing one of these secrets management tools, you definitely want to know who's got access to what and control that access, right? So with the secrets management tool, that'll help you immensely, right? Keep an audit trail of what secrets are out there, how the secrets are being doled out, who has access to those secrets, as well as being able to revoke any secrets that maybe get exposed, right? So if some bad actor gains access to a secret that was doled out by this system, you should be able to quickly and easily go in and revoke those and reissue a new secrets, right? So basically that was the presentation on a whole. I just want to recap some of the stuff I talked about. Let's talk about CI principles. For the most part, right, it's when you're writing and committing code often, it's a great way for your teams to collaborate around code. And that usually means that you have to commit your code as often as possible into a shared code repository. You definitely want to produce some sort of test execution on your code on every commit so that you can work that into your CI/CD pipelines. And then finally, my favorite feature of CI is the fast feedback loops, right? Knowing when your code is passing or failing, right? But failure is, for me, I think more valuable, obviously, than passing, because when you have a failure, some people take it as a negative, right? Like, oh, my code is jacked or whatever. I'm here to tell you that failure is good, right? That tells you that something's wrong and you're not pushing bad code right into a release. So look at failure as a good thing is my advice to you. When it comes to continuous deployment, again, that's just the ability to create release artifacts for your deployment processes. It allows you to validate those artifacts, right, and ensure that you're able to deploy to that artifact to whatever target environment. Could be a Kubernetes cluster, could be just a straight up Nginx, maybe a LAMP server somewhere, right? Whatever the target is. You can use continuous deployment mechanisms to, again, validate the applications, make sure your services are functioning, and also help you to achieve the application state that you desire. And if time permits, right, you can add a layer of failover recovery, right? So if your application is having an issue, should be able to fail and then recover on its own. With DevSecOps, right, shift the security actions to the left, meaning push those to the forefront. Like I mentioned before, with all these awesome security scanning tools that are easier to use, easier to understand, developers now have the ability to be empowered to perform a lot of these security scanning functions within their pipelines, right? Using that automation to perform that. And you can also apply those same shift left principles in security to scanning containers, right? And pretty much any kind of transaction within your automated pipelines, you can apply DevSecOps to, right? And also that shift left mentality. And then securing pipelines, right? Really simply, just implement a secrets management tool, right? And adjust it to use the policies that make sense to you. Integrate that secrets management tool into your CI/CD pipeline so that you can use that to generate strong random secrets and or credentials, right? And then you can manage those secrets and credentials using the auto rotation, auto replacement mechanisms within that secrets management tooling, so that you can ensure your pipelines are properly secured and minimize the vulnerability, right, or minimize exposure to bad actors within your pipelines. Well, that concludes my talk. I wanted to thank you all for showing up and listening to this talk. If you want to reach out to me, again, my Twitter handle is @punkdata, and I am very open to all kinds of conversation. Thank you very much.